we will find inverse Laplace transform for this problem. First, we have to pay attention at the denominator to see if we can factor, and potentially we have to do partial fraction. But in this problem, we cannot factor because s squared plus 6s plus 25, we can write as s squared plus 6s plus 9, and then 16. The first three is a perfect square trinomial, and 16 is also a perfect square. So we're going to write like that. So the top, we will write, let's just say we're going to find the Laplace, inverse Laplace transform. So the top will be for s plus 28. The bottom, we're going to write s plus 3 square plus 4 square. Right. What we see now is that at the denominator we have s plus 3 square, 4 square, so we pay attention to here and we look like that is the form that we're going to have. But on the top, either we have s minus a or it's going to be b, where this b is the same as that b. So I kind of grounded there. Right. So we still have the notation for the Laplace, inverse Laplace transform. The bottom is still s plus 3 square plus 4 square. Since we see s on the top, and it has to be, again, s minus a, so we're going to have, instead of s, that's going to be minus a. Whatever that is, have to be the same as the plus 3 here. So I'm going to say plus 3, like that. Now we cannot just add 3 to the problem like that, because we have 4 times 3 will be 12. So essentially we plus 12 into it, so we have to minus 12 back to keep it in balance. And then with plus 28. Right? And then we can split inverse transform for s plus 3 over s plus 3 square plus 4 square. We can split negative 12 plus 28, that is 16. Just put 16 outside. We have this one over s plus 3 square plus 4 square. Right. Notice that we can also put the 4 here outside as well. As a matter of fact, let's just do that too. So we're going to move the 4 on the outside. Right. And now to transform the s plus 3 over s plus 3 square plus 4, that is, but we look at this one, sorry. We look at s plus 3 over s plus 3 square plus 4 square. The top has s, so that's going to be e to the at cosine b to the t. So that will be 4. A is going to be negative 3. And then we have cosine of bt. B is 4. So that's what we have. Right. Next, the top here doesn't have s in it. If it doesn't have s in it, it has to be the same as b. So since b is equal to 4 here, we go to net 4 on the top. We cannot just multiply by 4. We have to divide back out to keep things balanced. So outside of the parentheses, we have 4. And inside the parentheses, we have exactly in this form. So which will be e to the at sine bt. So e to the a is negative 3t. And then sine of bt. right? Next, we have the Laplace transform of second problem here. So we will have, let's just say it with Laplace transform, inverse Laplace transform of 5 s plus 1 cube just put all of that together first. Right. Now the linear properties of Laplace and inverse Laplace transform. We can take out the 5 inverse transform, and on the top will be just 1 s plus 1 cube, and then 2 times inverse transform of 1 over s squared plus 1. We can also say y squared. Right. Now we'll take a look at the table of the Laplace transform. What we see is that we have n factorial over s to the n plus 1. So in this case, the 3 here is going to be 2 plus 1. So n is going to be 2. Yeah, so n is equal, sorry, not that formula. I mean this formula here. Just erase this first. What we see is a power of s minus a or x plus a here. And n is going to be equal to 2 because that corresponding to n plus 1 here. So that's going to be 2. And then a is negative 1. So the transform of that will be equal to 5. By the way, we're missing something here. Notice that the top we have to have n factorial. Since n is equal to 2, we're going to need 2 factorial on the top here. So that will be exactly the form of what we have. 2 factorial over s minus a to the n plus 1. Right. So we cannot just multiply. We have to keep things balanced. And so we have 5 over 2. That transform on the left hand side is e to the at, where a is negative 1. And then t to the n power. And n is, again, is 2. And then next, the inverse transform of 1 over s squared plus 1. That is easy. Look on this one, where b is equal to 1. So that's just pretty much sine of t. And that's all we have. Let me zoom out to see the whole problem. And that's how we find the inverse transform. We have to, you will be given the table of the Laplace transform, and then we'll just find the corresponding values, corresponding formulas.